Hello and welcome to Intermediate Algebra, Unit 6, Lesson 3, Video 2 of 2 on factoring special cases. In this video we will look at the cases where what you're factoring is the sum of two cubes or the difference of two cubes. So that's our two lesson objectives. Factor polynomials that are the sum of two cubes. In other words, two things that are perfect cubes of something that are added together, or in the case of difference, one is subtracted from the other. So we're going to start a little bit backwards here. I want to start with a multiplication problem. If we have a plus b times a squared minus ab plus b squared, if we multiply that out, we're going to distribute the a through the trinomial first. So a times the trinomial plus b times the trinomial. Then as we distribute, we get a cubed minus a squared b plus ab squared plus, now from distributing the b, a squared b, we usually write them in alphabetical order, that's why I did that, minus ab squared plus b cubed. And what you notice is that I have a minus a squared b and a plus a squared b. A squared b, they're like terms, so those will reduce to 0. And then I have a plus ab squared. Now this is not a like term to a squared b because the 2 is on a different variable, but it is a like term to this minus ab squared. You have an a to the first power, b to the second power, so those are like terms, and they cancel each other out to reduce to 0, and that leaves you with a cubed plus b cubed. So why did I do that? Well, if I started with something in the form of a cubed plus b cubed, and I was told to factor a cubed plus b cubed, I know that it factors to this thing I multiplied together, and that's where I get my formula from. Now that's factoring the sum of two cubes comes from this, so a cubed plus b cubed is equal to a plus b times, in parentheses, a squared minus ab plus b squared. And notice this trinomial does not factor. You would need a 2 there for it to factor. So once you apply this formula, the trinomial doesn't factor anymore and you're done. Now if I switch some signs around in the multiplication problem I switched the first two positive and negatives, and I do a minus b, but in the trinomial everything's added. When I multiply out, I end up with the difference of two cubes. So the formula for the difference of two cubes looks very much like the sum. It's just it starts with the subtraction sign, and then all of the remaining operations are addition in the trinomial. The sum starts with an addition sign, and then there's one subtraction sign, and that last one is always added. The truth is you really only need a cubed plus b cubed as the formula, because if b is a negative number, all of this would come out with the right signs. It would come out like that if you very carefully applied it, because when you multiplied a positive a times a negative b, you would get a plus ab when you subtract it. So these are your two formulas, the difference of two cubes, the sum of two cubes. Now the problem with using these is our number sense again. We went through difference of squares. The difference of two squares does factor. The sum of two squares does not factor. Here for cubes, they do both factor. We can factor the sum of two cubes. But when there's numbers involved, students sometimes have a hard time recognizing, oh, I have a perfect cube. So that will be something you'll need to work on. Here are the two formulas summarized. You might want to have this next to you when you're doing your homework and make sure it's in your notes. And here's some useful perfect cubes to know. Again, finding a chart with the perfect squares and perfect cubes and having that handy, and recognizing numbers that are a square of an integer or a cube of an integer will be helpful. But I put this here just for immediate reference in case you don't have one of those available. I should make one available in class for you though. So this means if x is 1 and x cubed is 1. If x is 2, well 2 times 2 times 2. Remember, we're not multiplying by the 3 that's in the exponent. You're writing the number down. 2 cubed is 2 written 3 times and multiplied together. You get an 8. So if you recognize the right column in each of these little charts here as being something cubed, that will help you. So I can recognize I have the difference of two cubes here. The x cubed, that's given to me. I mean, because I have an actual exponent of 3, which means I have something cubed. The 27, I would have to recognize that, oh, wait a minute, 27 is 3 times 3 times 3, so it is 3 cubed. So what I have is x cubed minus 3 cubed. So a is x and b is 3. I fit that into the formula. I replace a with an x and b with a 3 everywhere in the formula, and then when I can, I simplify. So I get x minus 3, then x squared plus x times 3 is written as 3x plus 3 squared is what gives me 9. You don't have to jump to this in one step. You might just literally fill in for the formula, then simplify, particularly when you start getting numbers in front of the first item that's cubed. That it's easier if you write out everything in very careful algebra and then do the workout. For example, this one has an 8 in front of the x cubed. Now this time I have a sum, but I do have a formula for factoring the sum of two cubes. If these are squared, I can't factor it, but because they're cubed, I can. So 8 is 2 to the third power, which means cubed, and 125 is 5 to the third power. It's helpful to recognize that. You look first for a common factor, though, because you may be able to apply this sum of two cubes, but maybe only after you pull out a common factor. 8 and 125 did not have a common factor, so then I recognize that 8 is a perfect cube and 125 is a perfect cube. So I get an a is 2x and b is 5y when I write my problem in this form here. And then I'm going to replace all the a's with 2x. Now when I square a, I have to be careful to also square the 2. And when I square b, I have to be careful to also square the 5, not just the y. And you see that down here. A squared becomes 4x squared. 2 times 2x times 2x is 2 times 2 times x times x. So that gives me 4x squared. And then b squared is 5y times 5y. The 5's multiplied together give me 25. The y's multiplied together give me the y squared. So once you recognize what's cubed, you have to work carefully to use the formula and make sure you do all the algebra right and simplifying. So here's one for you to try. It's very similar to some we've done. Turn the video off and try it on a piece of paper, and then take a look at the answer when you come back. Alright, you back? Here we go. 125 is 5 cubed, and x cubed is just x cubed. So I get 5x is a, the cube root of y cubed is y, and when we do radicals, you'll see that you could just take the cube root of each of these to see what these should be, but for now we're only going to work with integers and just kind of reason it out. So I have 5x is a and b is y, so I have 5x plus y because I started with an addition of two cubes. So the subtraction sign's in the second part of the factoring. 25x squared is from squaring 5 and squaring x. 5xy is from multiplying 5x times y. And y squared is from squaring what I decided b was. Hopefully you're getting that. So here's one where our variables don't both have cubed. This is clearly x cubed comes from cubing x, and 125 is 5 cubed. But I have y to the 6th. I don't know how much you've thought about this lately, but when you do y squared cubed, you're writing down y squared times y squared times y squared. And if you wrote those y squareds each out the long way, y times y times y times y times y times y, you would have 6 in a row. So the rule is when you raise an exponent to an exponent, you multiply the exponent. So 3 times 2 is 6. So y to the 6th can be written as y squared raised to the third power. So that's what I've done here. and 8 is 2 to the third power, so the cube root of this n term is 2y squared. So now I can see I identified a as 5x, and my b for my formula is 2y squared. I have to be careful again when I put these in the formula and simplify. So I get 5x minus 2y squared, and then in the next set of parentheses I get 25x squared. 2y squared times 5x is 10xy squared, and then 2y squared squared, the 2 gets squared, so that's a 4, and y squared squared is y to the 4th. So that is how you handle that when one is cubed and the other is to the 6th, or to the 9th. You could write it as to the third power cubed. Alright, let's see what we have here. We have another one for you to try, very similar, turned around a little bit. So please stop the video and try this problem, and when you turn it on, we'll look at the answer. Alright, you're back. I assume you did the problem, though I'll never know. What I find is that if I want to write this first term, 125a to the 6th, as a perfect cube, it has to be 5a squared cubed. And 64b squared, oh, I'm sorry, that should be 64b cubed in that. That's a typo there. That's 64b cubed. If you go back to the original problem, it was 64b cubed. That was just a typographical error. So that would be the 64 would have a cube root of 4, and the b cubed would have a cube root of b. So I get a is 5a squared, b is capital B is 4b. I plug into the formula. So when I square 5a squared, I get 25a to the 4th. When I multiply 5a squared times 4b, I get 20 from the 5 times 4a squared b. And when I square 4b, I get 16b squared. So here's another one. So far, we haven't had anything that had a common factor to come out first. But I look at this, and it's clearly something cubed because of x cubed, or that might be a pattern I'd want to investigate at least. But 54 is not a perfect cube, and 16 is not a perfect cube, so I don't really know what to do. What you have to do is pull out a common factor. 54 and 16 are both even, so they're both divisible by 2. So let's try that. If I pull a 2 outside, undistribute it in a sense, that leaves me 27x cubed minus 8 in parentheses. That can be factored as the difference of two cubes, where a is 3x and b is 2. So I've reflected that here, but I keep writing this 2 because it doesn't disappear, it just moved outside the parentheses. And when I'm done, I need to be able to multiply all this out and get back the whole 54x cubed minus 16. If I stop writing the 2, my answer will only result in 27x cubed minus 8. So I keep writing the 2, but then I do the rest of the factoring kind of as if it wasn't there. So I get 3x minus 2, that's a minus b. And then a squared plus ab plus b squared. So look for that common factor first every time, particularly if you don't see the pattern right away. So let's try this one. It's very similar. Shut the video off and come back and check your answer. Alright, you're back? There we go. So 56x cubed minus 7, there's a common factor of 7. That it's kind of easy to figure out because of the you have a 7 there. You could try that. The only other things that would work would be a 1. So 7 comes out, and then I'm left with 8x cubed minus 1. Those are each perfect cubes. 8x cubed is 2x cubed, and 1 is 1 cubed. So I fill into my formula. I keep the 7, because that's part of the problem. 2x minus 1 is a minus b, and then a squared plus ab plus b squared. Okay, so here's another one. It's a little tricky because we could factor this as the difference of two cubes, or we could factor it as the difference of two squares. I'm going to suggest you always start these with the difference of two squares. So x to the 6th is x cubed squared, and 1 can just be 1 squared. So if I go back to what I learned in the last part of this lesson, the first part of the lesson, difference of two squares, 64x to the 6th can be written as 8x cubed raised to the 2nd power, so it's a perfect square, and 1 can be 1 squared. So a is 8x cubed, b is 1, a plus b times a minus b. And what I see I have here is I have the sum of cubes times the difference of cubes. Now I apply the formula to each part here. These first two sets of parentheses come from the sum of cubes applied to 8x cubed plus 1. And the second set comes from the difference of cube. The last two sets of parentheses are from factoring 8x cubed minus 1. Okay, so now try this one. Notice they're both to the 6th power. Start with the difference of squares. And stop the video and try it and check when you come back. Okay, you're back. Here is what I did. Here is how I wrote this as the difference of two squares. So a was x cubed, b was 8y cubed. And I write these steps out because I tend to make mistakes. You should too. You shouldn't just be jumping to an answer. So I get x cubed plus y cubed times x plus 8y cubed times x cubed minus 8y cubed. The first set of parentheses is the sum of two cubes. The second set is the difference. And then I factor them in the first two sets of parentheses are from factoring the sum of the cubes, and the last two sets of parentheses are from factoring the difference of the cubes. And once you use the sum of cubes or difference of cubes, that big trinomial, that doesn't factor any further. So you can stop then. Alright, I hope you've understood what we did in this video, and you should try some problems. There were some posted with answers as well as homework you have to do. And get help if you need it. Please don't just go not understanding. Thank you for joining me for this edition of Intermediate Algebra.